Okay, so I'm going to explain how to solve a certain number properties problem. And this problem involves finding the unit digit of the product of three numbers. Okay, so the question might seem daunting, but it's a very systematic way of solving this problem. And so let's look at the process. If you're given or asked to find the unit digit of some number x, y, z raised to some power ab, for example, you can rephrase the question as, what's the unit digit of ab? The reason this works is because if you think about it, if I wanted to find the unit digit of the product of two numbers, let's say 235 times 235, the unit digit depends on only the unit digit of each number involved in the product. Because if I multiply 5 times 5, I'll put the 5 here, carry the 2 over, 25, and then this 5 will eventually slide down and end up here in the final unit digit. Any other number, 5 times 3, 15, would go to the left of the original number. So if I did 3 times 5, 15, it would go here. So all other numbers involved in the product will be one place to the left. So only the unit digits of each number contribute to the unit digit of the product. So if I'm multiplying this 44 times, that would be 235 to the 44. Well, only the 5 will contribute to the unit digit in the end. So I only need to know the unit digit of 5 to the 44 in this case. Okay, so now let's go back to our original question. Our original question asks us for the unit digit of the product of three numbers, 13 to the 804 times 17 squared times 29 cubed. The unit digit will just be the unit digit of 3 to the 804 times the second number would be 7 squared instead of 17 squared. So I'll put that here. And then the third number in the product, we can replace that with, instead of 29 cubed, 9 cubed. Okay, so in this particular case, we've simplified the problem, but we still have a little work to do because we don't have the ability, or we don't know how to calculate 3 to the 804. So, but we can find its unit digit, which is what we're interested in. And the way to do that is to look at the powers of 3 and see if there's a pattern. So 3 to the 1 is 3. 3 squared is 9, and 3 cubed is 27, but the unit digit is what we're interested in, so I'll put 7 here. Notice that we could have found the unit digit. Since 3 squared is just 3 cubed is just 3 squared times 3, we can multiply the unit digit by 3 to get the next unit digit. 9 times 3 is 27, and 7 is the unit digit. 3 to the 4. So we didn't see any benefit here, but you'll see the advantage as the numbers get bigger, that we can find the unit digit of 3 to the 4 by multiplying the previous unit digit by 3. And it's going to be 7 times 3 is 21, so the unit digit will be 1. Actually, 3 to the 4 is 81. But you can see that the process always gives us the correct unit digit. So the unit digit of 3 to the 5, if we don't know what it is, we can just say that the unit digit of 3 to the 5 is the previous unit digit 1 times 3. So this one will have a unit digit of 3. 3 to the 6 will have a unit, multiply the previous unit digit by 3, 9. So the actual values of 3 to the 5, here we get 2, 4, 3. But we don't care about the 2 and the 4. We only care about the unit digit. Likewise, if you multiply this by 3, you get 7, 2, 9, but we didn't care about the 7 and the 2, we only cared about the 9. So to get the next unit digit, again, we don't really care about the actual value of 3 to the 7. We only need to know that its unit digit is the previous unit digit 9 times 3. The unit digit of the result, 9 times 3 is 27. So this will have a unit digit of 7. If you've been paying attention, you might have noticed that we've got a pattern in the unit digits 3971, 397. So we can almost guess that the unit digit of 3 to the 8 will be 1, but if we actually go through and do this, 7 times 3 is 21. This will have a unit digit of 1. So the unit digits of the powers of 3 are 3971. And so every power of 3 that's a multiple of 4 has a unit digit of 1. Since 804 divides evenly into 4, it'll also have a unit digit of 1. If it were 805, the unit digit will be the next number in the cycle, 3. 806 will have a unit digit of 9. So in fact, if you divide and the remainder is 0, if you divide the power by the number of numbers in the cycle and the remainder is 0, then the unit digit is the last number in the cycle. If the remainder is 1, the unit digit is the first number. If the remainder is 2, the unit digit is the second number. So 806 would have given us a remainder of 2, and we divide by 4, the remainder would have been 9. Okay, so we know that the unit digit of 3 to the 804 is 1, so we can put 1 here. We need to multiply that by the unit digit of 7 squared and the unit digit of 9 cubed to get our final answer. So 7 squared is either calculated as 49, but if it was 7 to some large power, you would have to generate the powers of 7. Right now the powers of 7 and see if there's a pattern. And there is a pattern. So, but in this case, we can just say that since this is a small power, that our unit digit will be 9 in this case. And 9 cubed, again, 9 squared is 81, 9 cubed is 243. Sorry, 81. 81 times 9 is 729 actually. So 9 cubed is 729. It will also have a unit digit of 9. But if it were some large power, we could still find the unit digits. So I'll come back and explain that quickly. But so in this case, unit digit of 3 to the 804 is 1. 7 squared as a unit digit of 9. 9 cubed as a unit digit of actually 49. 9 cubed will have a unit digit here of 9 as well. So we can conclude that 1 times 9 times 9, which is 81, tells us that the unit digit of our final answer is 1, which is answer choice E. Okay, so if this were a larger number, you would just have to generate the powers of 7 and see what the pattern is in the unit digit. For example, if this were 204, then you would have to write out 7 to the 1 is 7. 7 squared will have a unit digit of 9 because it's 49. 7 cubed. If you multiply this by 7, 63, the next number will have a unit digit of 3. And so we don't care what numbers precede any of these numbers. We only care about the unit digit. The pattern so far is 793. And if we did 7 to the 4, it's just the previous unit digit. This unit digit would be the previous unit digit times 3, times 7. 7 times 3 is 21. So the next number, 7 to the 4, will have a unit digit of 1. So you can verify that the powers of 7 have unit digits 7931. Okay, so if it were 204, again, because it's a multiple of 4, we'll divide by 4 and find that the unit digit of 7 to the 204 is the last number in the cycle 1. But if it were 202 instead of 204, then the unit digit of 7 to the 202, divide 202 by 4, which is the number of numbers in the cycle for the powers of 7, you would get a remainder of 2, which tells you that the unit digit of 7 to the 202 will be the second number in the cycle, because the remainder tells you the position in the cycle where the unit digit can be found. So the remainder of 1 means that the unit digit is the first one of the cycle. Remainder of 2, unit digit is the second one. If the remainder is 0, then the unit digit is the last one, because if you divide any number by 4, and the number is a multiple of 4, the remainder will be 0. It'll be the last number in the cycle. So that would be how you would do it if the power had been 202 instead of 2. But I tried to keep this simple because obviously, if you can do the first one, if this were 202 or some other large number, you should still be able to do it. So it's a process that's important, and you end up with a 1. So I hope that all makes sense. And so I'll be posting more videos, so stay tuned, and I hope you enjoyed this.